Okay, topic 5.3, arcs and chords. The first one up here is a definition, and a chord is just a segment with two endpoints on the circle. There's a theorem that goes with chords. In a circle or congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So what that kind of means is if you know the degree of the arc, then you know the chords, well, if they're congruent. See, the markings on this first example have these congruent, so they want to know which of the chords are congruent. That's just from the tick marks. So AB is congruent to CD. And to get the measures of these arcs, they all have to add up to 360. So if they've given you 20 and 220, that's 240. If you did 360 subtract 240, that's going to be 120. And then because there's two equal chords, you'll divide 120 by 2. So that means each of those chords are 60 degrees. This one and this one. I'm sorry, not the chords, the arcs. The arcs are the same because the chords are the same. Alright, we're going to use that theorem working with example 2. On example 2, PS is a chord and it has a length 12, and TR has a length 15, and they want us to find the length of, let's see, QR. Let's see, 50. Okay, if you were to take from this arc, from P all the way to S, that means you're going to add the little arc 20 and 50. See how that's 70 degrees? So even though the drawing doesn't really look right, the chords have to be equal. So since PS is 12, PS is a chord that has to be congruent to RQ, or QR, I guess they're naming it. They have to be congruent, so that means it's also 12. And sometimes they do draw the chords in, you know, not to scale, and they won't put the right drawing. It won't look right, but it is congruent because of the measurements. Okay, HI on this one, if you take your 78, your 91, and your 113, if you add all of those together and subtract that from 360, let me do that really quick. Okay, sorry. This answer is 282. Since 360 is the distance all the way around, my pen's kind of getting dull. Let me get another one. 360, we would subtract 282 from 360. That would give me 78 degrees. If you'll look, 78 degrees is also the length of the arc GH. So GH and HI are going to be congruent. If the arcs are congruent, the chord lengths are the same. So HI would be 9 also. That's just using the theorem. Two minor arcs are congruent if and only if their corresponding chords are congruent. Okay, turn the page and let's look at the next theorem. On the second page it says, in a circle, if the diameter is perpendicular to a chord, then it bisects the chord and its arc. Let's go ahead and tick mark what that means. It bisects it right here. Now it also, well, we'll talk about that later. On this one, ED, let's see what this is. Oh, it does tell us they're perpendicular. They are always perpendicular. You can draw a little right angle box right there. And it tells us that that length, not the entire radius, but that part of that radius is 7.5. Okay, do you see that it tells us the length of the radius is 8.5? So if you subtract 7.5 from 8.5, that's going to give you the length of the remaining part of that radius. So that would have to be a 1 right here. Now I'm going to go ahead and I'm going to draw a dotted or a dashed line from A to C. That radius is 8.5. And I want you to notice that you have a little right triangle. I think I'm going to sketch it right here just to show you. In that right triangle you have a hypotenuse of 8.5 and a leg of 7.5. So because you need to get this length right here from E to C, let's do the Pythagorean theorem real quick. So it'd be a squared plus, sorry I'm writing kind of small, oops, I'm sorry, that's 7. The hypotenuse has to be the longest side. So if you do a squared plus, if you square 7.5 you get 56.25. If you square 8.5 you get 72.25. So your a squared would equal 16. So your a is 4. I'm going to go ahead and explain. That means the leg right here. Now I want you to notice that if you were to draw another radius from A to B, you really end up having two triangles here that are the same. Remember, this piece and this piece are congruent from our theorem. So this segment from AE is also 4. Alright, let's answer the following measurements. ED, we already figured that out, that's 1. AC, that's a radius, so that's 8.5. AB is also a radius. EB is one of the segments we just figured out. EC is the same. And BC is the entire segment, so you would add the two 4s. So that would be 8. Example 5, if the measure of CFB is 220, CFB is going to be this major arc from here to here, and that's going to be 220 degrees. Well, if you took 360 and subtracted 220, that'll give you your minor arc, so that's going to be 140. Now, 140 is the arc CB. CAB, I think I will go ahead and draw that one in too. It creates a central angle, so it's going to be the same degree as the arc. BAD is going to be half of the central angle, so that's 70. CD, if the arc here is, if this one's 70 degrees, the central angle out here is also 70 degrees. Alright, example 6. In circle A, SQ is 12. Now because it's hitting at a right angle right here, that means it's bisecting that chord. So if SQ is 12, those pieces from S to T and T to Q are both 6s. AT is an 8. So just be careful, that just means that this little triangle right here is 8 and 6. Now if we did the Pythagorean theorem to determine the hypotenuse here on this triangle, we're going to have 6 squared plus 8 squared. This is actually a Pythagorean triple. They call it a Pythagorean triple because all the answers, all the side lengths are whole numbers. So 10 is the length of the radius. So AR has to be 10. I'm going to go ahead and label AS. If AS is 10, AR has to be 10. So that's the radius. That's the length of the radius. Now let's go to example 7. Okay, on this one we're using another diagram they've already drawn. Now look at this one. It's giving you a 60-degree central angle, so it's creating a 30-60, right here, a 30-60-90 right triangle. The hypotenuse is always double the short leg. So in this case, if you want to figure out the short leg of a 30-60-90, you just take half, and half of 5 is 2.5. So that's going to be your answer for Y. If you're wanting to find the long leg of any 30-60-90, it's always whatever your short leg is, this will be the long leg is the short leg times the square root of 3. So that's 2.5 times the square root of 3. This is just a review of 30-60-90 triangles. AB is an arc degree, so it would create this 60 degree twice. I can't really draw it for you, but you would double this one, because if this piece is the same as this one, then you would take this degree of 60 and double it. So that makes 120 degrees. That's example 7. We're going to learn a new theorem on the next page. In a circle or congruent circles, two chords are congruent if and only if they are equidistant from the center. So if you look, in the drawing here, they've drawn tick marks to show you that they are the same distance from the center. So that does mean these chords are equal. If you'll notice, this is at a right angle here, so these are also. That's from the other theorem on the other page. So if this is 8 and 8, that means the entire length is 16. So your x is 8 and your y is 16. In circle O, example 9, FL is 3. If FL is 3, then LG is also 3, because these are always going to be congruent. Remember, that's from an earlier theorem. If the chord hits a radius at a right angle, that means they're congruent. GO is a radius, that's 5. So if they've labeled if I can label OG 5, I can label OJ 5. They're both radius. Now OP is not 5, be careful. OP is 4, but it's not a radius. This is actually another Pythagorean triple. I'll show you. If you find, I'm going to call this one A, I guess. So A squared plus 4 squared would equal 5 squared. A squared plus 16 is equal to 25. A squared would equal 9. So A would be 3. This is a 3, 4, 5 right triangle. So this length is 3 and this is 3. So HJ would be 6. You would add the two pieces together. These are always going to be congruent if it's at a right angle to the center point. It's really describing a piece of the radius, but if it's at a right angle, the chord is bisected, it's cut in half.